class. All right, so let's see if I can find there.
I'm going to use this route because I found vector an in part 1 of the question. I now have equals
So remember, the first thing I
vector
need to find
ma
here is vector
an. I know that vector AC is vector y, and I also know that M is the midpoint of AC. So I is a half of vector y. I'm going to use vector AN from here. That's a half of vector x plus a half of vector y. I can now simplify this. Minus a half of vector y plus a half of vector y is 0, so I'm just left with a half of vector x. So vector mn is a half of vector x. If I now look at vector AB, I can see that that's vector x. If I compare this with vector mn, which is a half of vector x, I can see straight away that the directions are the same, but that this one is a multiple of this one, so they must be parallel. So I now have that the line MN is parallel to the line AB.
This is the proof. If two vectors are parallel, then one must be a multiple of the other. If two vectors are parallel, then one must be the multiple of the other or the factor of the other. Same rule is applied if you're asked for collinearity. You address it just like this. One of the vector must be a factor of the other or a multiple of the other. That's all you need to know about collinearity and parallel vectors. So the same rule that is applied to parallel vectors is the same rule that is applied to collinearity. And collinearity is stating to you that 3 points, 3 given points are on the same line. That's collinearity. So for 3 points to be collinear, then the 3 points must be on the same line, and a part of that line must be a factor of the whole line. When we get to collinearity, you'll understand clearly what I'm talking about. Is that clear to everybody? So the same rule that is applied to parallel vector is the same rule that is applied to collinearity. All right, let's continue.
Press pause and have a go at it. When you're ready for the answers, press play.
Pay keen attention to words like midpoint, to the ratios in these questions. CSEC love to send questions like those, right? Like these at the vector section. All right. So let's move it.
At it. When you're ready for the answers, press play. Here's the answer to part 1. Here's the answer to part 2. I had to start by finding vector PQ, which I found to be 2 of vector Y. I'm told that vector AD is 6 of vector Y. So I now have that vector AD is 3 of vector PQ. As vector AD is a multiple of vector PQ, then they must be parallel. Here's a question where you're going to do part A and then I'm going to do part B. Press pause and have a go at part A only. When you're ready for the answer, press play. Here's the answer to part A.
Pay attention
For the
to
second part
B.
of the question, I'm told that the midpoint of CB is M. This is the stage where I'm going to show you how to prove that 3 points lie on a straight line. My strategy for this question is going to be find For the second part of the question,
Is AC equals to. So AC is equals to DC. No. AC is equal to AD. AD plus DC. And that is going to be AD is going to be negative 6A. Negative 6A plus 6C. Which is the same as 6C minus 6A. Mm-hmm. 6A. So that is AC. Good. But DE now, DE is moving from D to E. So this would be DE with equals to DC minus plus rather a third of AC of CA, a third of CA. A third of CA. And so this is going to give me 6C minus 1/3, minus 1/3 of 6a minus 6c. And when we do that, we get 6c, yeah, 6c plus to this, plus 2a minus 2c, which is equals to 2a plus 4c. Plus 4c. Keep doing that, but this should be 4c. Plus 4c. So this is how it is worked. Understand, Caris? Clear to you now, Caris? Or we arrive at this? All right, so let's continue the video. Clear this first. So note the step that should have been taken and move along with it.
I'm told that the midpoint of CB is M. This is the stage where I'm going to show you how to prove that 3 points lie on a straight line. My strategy for this question is going to be find vector DE, then find vector DM. If I can show that vector DE is parallel to vector DM, then they must lie on a straight line because they have a point in common. From the first part of the question, I already know vector DE. For vector C. I now want to find vector DM. To get from D to M, I'm going to go from D to C and then from C to M. I know that this shape is a parallelogram, so I know that this is parallel to this. I also know that M is the midpoint, so this must be 3 vector A. Now vector DM is vector DC plus vector CM. I know that vector DC is 6 vector C, and I know that vector CM is 3 vector A. I now have the task of showing that this is parallel to this. To do this, I'm going to factorize them both. For vector DE, I now have 2 vector A plus 2 vector C. For vector DM, I have 3 vector A plus 2 vector C. I now have that this is a multiple of this, so they're parallel. They have the point D in common, so they must lie on the same straight line. So I've proved that DEM is a straight line.
Any question? Any question? Is that clear to everybody? Yes. In the workbook, I want you to look at the question on page 72 of the workbook. Let me share that screen. Workbook 2. Are you seeing the screen? Are you seeing the screen, everybody?
Yes, sir. Yes, sir.
So
Yes,
that's the question that you're going to look at. You're going to answer that question. And you won't get a full length vector question in the exam because vectors mixed with matrices since I think 2015, somewhere there, right? So you won't get a full vector question, but it is good to familiarize yourself with every aspect of vector. So we're going to look at the question now. Best to write out the equation. So this is A up here and B. So AB would equals to 3x because AB is equals to AB is equals to DC. Explain, where are you confused with? Angel and Caris? You're given a parallelogram, ABC. No man, it's just labeling that. How do we get a A? It's just labeling. All right. The diagram should have had all of those. It's just printing error. All right, so A, B, C, D. So AB is the same as, because a parallelogram, AB is the same as DC. So this will be 3x. And BD, now BD would be from B to C and then from C C to D. And we're moving in the opposite direction. We're moving in the opposite direction. So this is going to be equals to negative 3y, negative 3y minus 3x, or negative 3, this could equal to negative 3 to y plus x, right? So that is what BD is. Okay, so the next part of the question asks us for DP. For DP. Now, what do we know about P? We are told that DP to BP to PB is 1 to 2, which means that the line BD or DB, this line is cut into 3 parts. So DP is equals to 1/3 of DB. One-third of DB. And so this is equals to x plus y. X plus y. Any question? Because if BD is negative 3 bracket x plus y or y plus x, then DB is going to be equal to positive 3 bracket x plus y. And DP is 1/3 of that, so it will be x plus y. Any question? Any question? All right, no question. All right, no question. So next we're asked to show that AP is equals to x minus 2y. So AP, which is here. How we get to AP? To get to AP, so AP, to get to AP, we have to move from PD, and then up to P. We know that PD, did we calculate PD? Yes, we calculate DP as this. So this is going to be negative x minus y. And then AD, this should be AD. AD now would be what? AD is negative 3. Why? Something wrong here, so. The P, so the P here. So the P here, Let me clear it for you. So the P there. Let me go over this. Let me go over this. AB. So we want to find, to show that this is that. All right. So we're moving from A to D, which is negative 3y. And then we're moving from D to P plus X plus Y, right? Plus Y. And so we would have gotten this to be X minus 2Y. So that's how we show it. Yeah, I don't know what had happened a while ago to me. All right. Now you're saying, given that E is the midpoint of DC, so right here, for argument's sake, is DC, is E. Show that A, P, and E are collinear. So what we want to find for this, we already know what is AP. We already know what is AP. So what we need to find is what is AE. What is AE? The line AE. Now AE is equals to AD plus DE. Work that out for me and tell me what you get. This is negative 3y, right? Negative 3y plus 1.5x. All right. Factorize this. As I said, I rather to put this. So this is 1.5. 1.5 x minus 3y. And when I factorize this, I am going to get 1.5 x. 1.5 into x minus 2y. What we notice is that we have this and we have that. So therefore, that proves that the point A, P, and E are collinear. So you see the linkage. You see the linkage? So once you work it out, you do your factorization, and where you see the commonality, then that proves that the points are collinear. So all you need to do is to write a statement stating that that AE, vector AE is equals to 1.5 of AP. 1.5 of AP. All right, so vector AE is equal to 1.5 that. So the rule is this: AE must equals to K, which is a scalar, times AP. That's the rule for collinearity. All right. Any question? Because this is where we're going to stop. You can try this one on your own. Know the principle of isosceles triangle. In this sense, you're not finding angle, but you're going to prove that two sides are equal. The length of two sides are equal. But this one, all you're going to prove is that you have two equal vectors, or the magnitude of the two vectors are equal. And once you get that, then you know it's an isosceles triangle. All right. Any question from anybody?
No, sir.
Everything is clear?
So kinda.
Yeah, with practice, you'll be able to master it. So there are a whole lot of questions on it. Whole lot of questions. See one here about parallel. There, 3 points, midpoint. Then you have, look here, two geometrical relationship that exists. Let me see if any more. See another one here about collinearity. All they need to do is to practice them. Yeah, go into it. See it here, prove that these 3 points lie on the same line. Collinearity again. So they are there, practice and practice until Wednesday. Next session will be tomorrow, after the English exam. All right. So that's where we are going to be ending our class for